Okay, right, so here is how you actually do part B, okay? Now the clue I suppose it is given you, it's not a brilliant clue, I have to be honest, is that you have to use integration by parts. Let me just get rid of this. And you know that you use integration by parts when you want to integrate a product. So you've got the integral is this differential, this integral here, pi over 2, 0 of sine to the power of n x with respect to x. It's n, not the 2. So you're looking at that going, well, I can't really do integration by parts on this, but what you can do is you can just adapt it. And this fundamental step is why this question is so difficult. I mean, how are you meant to know to do this? But write it out like this. Sine x times sine to the power of n minus 1 x with respect to x, okay? Now we can use the integration by parts formula on this. We can let u equal sine to the power of n minus 1 x, and we can let, so let's just do the formula quickly, just so that you actually remember how to do integration by parts. So integration by parts is if we integrate u times dv dx, that is equal to uv minus the integral of v du dx with respect to x, okay? And so we need to make a selection of u and dv dx, so we pick dv dx as the one that we can actually integrate, which is sine x. We can integrate sine x very easily. So dv dx is sine x, and that means that v is equal to negative cosine of x. And du dx, we're going to use the chain rule. Okay, so we're going to let u be equal to sine x, which means y is equal to u to the power of n minus 1. dy du is equal to n minus 1 times u to the power of n minus 2. du dx is equal to cos x. So I'm going to get n minus 1 times cos x times sine to the power of n minus 2x. So let's just write that in there. N minus 1 cos x sine n minus 2x. And let's just delete that working out. Okay, so now just applying the formula, we will get that this is equal to uv, so that's minus cos x sine to the power of n minus 1 x minus the integral between pi over 2 and 0 of v du, sorry, it's what am I doing? I've totally lost my train of thought now. It's uv minus v du dx. So it's this times this. Okay, yeah, that's right. That makes sense. So I'm going to get minus cos x squared. So I'm going to change that to a plus. And I'm also going to take the constant to the outside. So just hold on a second. So I'm going to get plus n minus 1 times the integral between pi over 2 and 0 of cos squared x times sine to the power of n minus 2x with respect to x. Okay? And don't forget that this is a definite integral, so this also needs to be between pi over 2 and 0. Now the good thing is about this, if I put pi over 2 and 0 into this, into this expression here, I'm going to get 0. So that's just going to disappear because sine of 0 is 0 and cosine of pi over 2 is 0. So whatever way you cut it up, you're going to get nothing. And so that just disappears. So that's good. So now I'm left with this, n minus 1. I'm just going to write this again. This is important. n minus 1 between the integral between pi over 2 0. I'm going to change that cos squared to a sine squared by changing that to 1 minus sine squared x times sine to the n minus 2 x with respect to x. And so follow through. I'm going to get n minus 1 times pi over 2 of 0 of, if I expand the brackets, I'm going to get sine to the power of n minus 2 of x minus sine to the power of n x with respect to x. Okay? Now, here's the really clever bit that really don't know how, again, you're meant to spot it. But this, basically I can write it like this as well. Let me just highlight them. This bit here is I of n minus 2. And this bit here is, or rather all of that, I of n. Okay, so I can just basically replace these pieces with what I know that they happen to be. And now it's a simple case of trying to rearrange the formula to make in the subject. So divide everything by, divide everything by n minus 1. So in over n minus 1 is equal to I of n minus 2 minus I of n. So I of n over n minus 1 plus I of n, take n's to one side. Okay, now multiply everything by n minus 1. Equals n minus 1 times I n minus 2. So I'm just running out of space. I can go to the left here. So I'm going to get, basically, if I expand that bracket, I of n minus I of n disappears. So I'm going to be left with n I of n equals n minus 1 of I of n minus 2. And now divide both sides by n. I of n is equal to n minus 1 over n of I of n minus 2. And so there it is. How they can reasonably expect a year 13 student with not much mathematical experience to deduce something like that, I have got absolutely no idea. I can only assume that this particular question is designed for the maths prodigies. So you've got to be realistic, you've got to be strategic, and when you get stuck into that question and you realise that it's a nightmare, probably just leave it. Okay, and if you get time at the end, you might be able to go back and have a stab. The problem is it's difficult from the very offset, so it's not like there's even opportunities for you to pick up a few method marks by using integration by parts if you didn't even know how to sort of split it up in the first place. But what can I say? It's going to be difficult. Okay, so again, I'm going to stop the video there, and then we'll